Hello friends, welcome to the lecture 5 of Digital Electronic series. So in this Digital Electronic series, we'll first see what is neutral function. So what is neutral function? Any Boolean function whose number of max term equals to number of mean term is known as neutral function, right? Now let's say we have n variable, n Boolean variable, right? In n Boolean variable, we know that total number of rows is how much? Let's say we have a1, a2, Boolean variable a1, a2, a3 till an. So this can attain maximum how many values? 2 values. So 2 into 2 into 2 into how many times? N times. So total number of rows was how much? It was 2 raised to power n, right? And we know that any Boolean function whose max term will be equal to min term. So what is max term here? Values with 0. And what is the min term here? Values with 1, any of the rows, right? So if I need to find out how many total rows shall be equal to 0 and how many rows shall be equal to 1, so that it is a neutral function. As we know, the total number of max term will be equal to the mean term. So let's say total number of max term is x. Total number of mean term will be also x, because it has to be equal. And sum of these two should be what? 2 raised to power n. So x will be definitely 2 raised to power n divided by 2, which is nothing but 2 raised to power n minus 1. Right? So x equals to 2 raised to power n minus 1. What it means? It means the number of rows which having mean term will be 2 raised to power n minus 1, and the number of rows which having max term will be 2 raised to power n minus 1. Now let's find out total number of dual function, it's a neutral function. Total number of neutral function for n variable, right? So total number of total number of neutral function for n variable, how we will compute? Okay, so we must have exactly this many min term, right? What is the total number of rows we have? It is 2 raised to power n. Out of 2 raised to power n, that is out of these many rows, we need to choose exactly these many for being neutral function. So if I choose exactly these many mean term or these many max term, the others will be, if we choose mean term, other will be max term. If we choose this max term, other will remaining will be mean term. So this is the total number of neutral function is possible with n variable, right? Now let's take one simple example. Let's say we have 3 variables, so A, B and C. In this 3 variable, possible number of rows is 8. Why 2 raised to power 3? 0 0 0 0 0 1 1 0 0 1 1 0 0 0 1 1 1 0 1 1 1. Now I have a function f, right? So first of all, question could be check whether this function is neutral or not. So AB plus C bar, check whether this function is neutral or not. How we will check whether it is neutral or not? AB, the outcome of this function, should be equal number of ones and equal number of zeros. So in this case, this will be equal when A and B both has to equal. So A and B both has to equal, right? So this is the case when A and B both are equal, and in this case also A and B both are equal, right? Or C could be 0. So C could be 0 in this case, in this case, in this case, in this case, right? So what are the total possible rows for this f? F will be 1, F will be true. F will be true in which cases? Let's write in min term. It is 0, it is 2, it is 4, it is 6 and 7. So count how many min terms are here. 1, 2, 3, 4, 5. 5. And total number of rows here is 8. Oops. If total number of rows is 8, then for this function to be neutral, f should be true only at 4 rows, right? So exactly f should be true at 4 rows, that is 8 divided by 2. Total number of rows divided by 2, right? That should be the case for f to be neutral, right? So we have to find the neutral function. So if the function has to be neutral, we should take, let us suppose I am taking this one also, this one also, and this one. In order to make Boolean expression out of this, right, what we need to do? It's a simple, if I write in canonical form, f is what? A bar, B bar, C bar, right? This is plus A bar, B bar, C plus A, B bar, C, sorry, A bar, B, C bar, and this one is plus A bar, B and C. Now we have 4 term here, right? And this 4 term is obvious, it is in the form of it is a canonical form. So if it is a canonical form, so this function f will be true only in this case, in this case, this case, this case. Since this is a function of 3 variable, total number of mean term is 4 here. So what will be the total number of max term? It will be total minus 4, which is 4. Since these two are equal, and which is half of the total number of rows, so this is neutral function. Okay, next we will see self-dual function. So what is self-dual function? Boolean function is self-dual if it is neutral function. Just now we have seen it, neutral function, right? And it does not contain any mutually exclusive term, and function should not contain any mutually exclusive term, right? So what is mutually exclusive term? What is mutually exclusive term? Now again let's write the truth table. If it is 0, if C is 0, then A should 1. Sorry, if C is 0, then C should 1. That is, if we have A, B, C, just apply not on each of these literals. So this will be A naught, B naught and C naught. So these two are mutually exclusive term. So as you can see, these two are mutually exclusive term. These two are mutually exclusive term. These two is mutually exclusive term. Again, one missing. 0, 1, 1. And again, these two are mutually exclusive term. Right? So if I say A, B, bar, C, what is the mutual exclusive term? Just not of it. Not of not B is what? B again. So it will be A naught, B, C naught. Right? So Boolean functions are mutually exclusive. Right? Just apply the not. So what is self-dual function? A Boolean function is self-dual function when it is a neutral function, that is equal number of maximum and equal number of minterm, and when it has no mutual exclusive term. Now if I say this was the decimal value of ABC is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we know 0 and 7 are mutually exclusive to each other. 1 and 6 is mutually exclusive to each other. 2 and 5 is mutually exclusive to each other. 3 and 4 is mutually exclusive to each other, right? Right? Okay. Now, in this, any function if it is given, right? Any function if it is given, let us suppose the function is given in terms of canonical mean term, it is 7, 6, 1, 4, right? So first we need to check how many Boolean variables are associated with this function. If it is 3, what is the total number of rows possible? That is 2 raised to power 3, that is 8. So if total number of rows is 8, the total number of mean terms should be 4 only, because half of that, because that self-dual function has to be neutral. So for neutral, if total number of rows is 2 raised to power 3, that is 8, and mean term maximum is equal, so divide by 2, which is nothing but 4. So total number of mean term for a self-dual function, because in turn it has to neutral function, so it has to be only 4. Okay, fine. 1, 2, 3 and 4. Fine. So this is neutral function, right? Now next check whether this function contains any mutually exclusive term or not. It should not have, right? So as we know, 0 and 7 is mutually exclusive to each other. Since 7 is present here, 0 is not present here. Fine with it. 7 is fine. Now check with 6. Oops. 6 and 1 are mutually exclusive to each other. So if both of these terms out of these 4 for 3 variable, if both of these term is present in min term or in max term, then this function is having mutually exclusive term. If it has mutually exclusive term, we can say that this is not self-dual function, right? So now in that case, what we need to do, we need to now okay, you know how to check this function to be mutually exclusive. If function is given, let's say f is ab plus b bar c, right? So the best idea is to just convert in canonical form. So what will be that canonical form? ABC, if you remember in my previous lecture, just go back and see how to make canonical form. Just if any literal is missing, just make it a plus a bar b bar c. So it will be a b c plus a b c bar a b bar c plus a bar b bar c. Now if we have a Boolean expression in canonical form, just find out whether it is self-dual or not in the similar fashion. So what is this? This is 0, right? This is 0. Not exactly says 0. Okay. Total number of rows for this function, since this is 3 variable Boolean function, total number of rows is 8, and since total number of rows is 8, so for being neutral function, the total number of terms should present here 4, which is correct. Fine, there are 4 terms. Now check whether there is a mutually exclusive term or not. Okay, so if a b c is given, there should be no a bar b bar c bar in this term. Okay, there is no a bar b bar c bar in this term. If we have a b c bar, there should be no any term a bar b bar and c. Oh, these two are mutually exclusive. So this function is not at all self-dual function. Although it is neutral function, but it is not self-dual function, right? So how many self-dual function is possible? For 3 variable, how many self-dual function is possible? Okay. So for 3 variable, what were the mutually exclusive term? It was 0 or 7, 1 with 6, 2 with 5, 3 with 4. Now for self-dual function, we need to have any one of this. So how many choices we have? 2 choice. Here how many choice we have? 2 choice. How many choice? 2. Right? Okay. So total number of, is it visible here? So total number of neutral function will be 2 raised to power 4. right? 2 raised to power 4 in case of 3 variable. Now if it is n variable, so what is this n? This is 4. What is this 4? This is exactly number of, that is n by 2, right? Total number of rows divided by 2. So I can write total number of self-dual function for n variable will be, there will be how many rows? 2 raised to power n. So if there are 2 raised to power n, how many mean term is there? 2 raised to power n by, 2 raised to power n divided by 2, right? And picking up from this is what? Any one can be picked. This is these many pairs for mutually exclusive term, right? So 2 raised to power number of pairs, and this is number of pairs, that is 2 raised to power n minus 1. Total number of self-dual function. So what is the relation between neutral function and self-dual function? A self-dual function is only possible if it is neutral function, right? So can I say neutral function is a superset of self-dual function? Of course. A self-dual function has to be first neutral, right? So if I have a set of, let's say, neutral function, right? Or I should write a set form. Neutral function, then this set is what? Self-dual function. Boolean expression can also be evaluated using this Venn diagram. So let us suppose this P, Q and R are Boolean variable, and we need to find the Boolean expression for this shaded region. So let's first make these 3 Boolean variable P, Q and R. If I say, what is this area? This one consists P also present, Q also present, R also present. So this is nothing but P, Q and R. This is nothing but P, Q and R. Right. This one is P, Q and R. What is this one? This is what? P present, Q present, but R is not present, right? So this is P dot Q, but R is not present. So P dot Q product, that is and R not, right? Similarly, this one is P present, R present, but Q is not present. This one R, Q present, but P is not present, right? What is this reason? This reason is what? We have R only, but not P, not Q, right? So what is this shaded region? We need to find this one, right? So this whole Q plus this region, this is what P and Q, P and R present, but Q is not present. So P and R present, but Q is not present. This is the answer. Now let's move to the next problem. This is, what is this reason? This reason is P dot Q. This reason is Q dot R. In one goal, what you will do? You will straightforward write answer what? Straightforward you will write PQ plus QR, right? Which is wrong. When you are considering these two, right, you should also consider the third variable, right? So it is P and Q and R is not present. We should mention this R is not present. So there could be R mapped here also. But in this case you are not writing any R here. Plus this reason is what? Q dot R, but P is not present here. So this is the answer. Now let's solve this one. What is this reason? This is X dot Y dot Z. That is ANDed of all these three Boolean variable. Now what about W? W is also present here, right? So we need to write ANDed with W also, right? So this is the answer. Now Boolean expression can also be evaluated for digital circuit, right? So we have a digital circuit here, right? So in this circuit, if you see, the complete circuit is only possible if we put some bulb here, right? So this bulb will only glow when P and Q are in serial, right? So P and Q are in serial. When it is serial, you have to ANDed it, right? So in P and Q, so instead of these two, I can write P and Q ANDed with any of one of these, right? Any one of these means either R glow, R switched, or S switched. So answer will be PQR plus PQS. That's all for today. Hope you liked the video. Please share, subscribe and like. Thank you.